long way from home.
That's right, about 500 miles, 550 miles.
What's this airplane called?
This airplane is called an Acrolite, and the model is a Model 1T.
Now, the Acrolite, when I first saw it, only had 2 wings. This one here's got 3.
Yeah, well, the original Acrolite was the 1B, the one over here. This is the one that won the Aircraft Spruce and Specialty Design Contest in 1996.
Talk a little bit about that. How did you get involved in that?
Well, Aircraft Spruce was advertising a design contest for scratch-built airplanes because they wanted to sell, kits and parts. And I entered it, and out of 101 entries, I managed to win it.
No, it wasn't just a matter of winning it, though. You also had to build an airplane.
Yeah, well, what Aircraft Spruce did was that, after they actually selected 3 aircraft to build. One of the fellas dropped out right away. The other fella, last time I talked to him about a year ago, still had parts scattered all over, and that's almost 8 or 9 years ago now. And we built this one here. We built this one here in a little less than a year to get it ready to fly into Oshkosh.
Now, are these basic airplanes using the same type of construction?
Yes. All of the airplanes are the same. There's 4 different models.
Let's just start with is there a difference in the basic model, or how do we start with the first model?
Well, this is the first one here, and it's a steel tube fuselage, fabric covered. The tail is aluminum tube with gusset plates, aluminum gusset plates, blind riveted. This airplane here has a wooden wing. There's a conventional wooden wing box spar construction.
So we've got a welded 4130 chronoly fuselage.
Yep.
And then we're covering it with standard aircraft type fabric covering?
Yep. Polyfiber covering, the lightest fabric they have.
Now, what type of wings are we using? Wood ribs in it as well?
Yes, and this one here, there's built up 3/8 square spruce ribs.
And what about the spars?
The spars are a wood squares, about 1.125 by 1.125 square, with plywoods on each side, so it's a box spar. That's the way we get away with just one strut and one interplane strut, is because all of the torsional load in the wing is taken up by the full sheeting in the box spar.
Okay, now the average guy, what would he need if he were to buy a set of plans? And I believe that's what you're selling them as, these plans now?
The Acrolite 1B, because Aircraft Spruce sponsored it, they have the marketing rights to the plans. So for that model, you have to go to Aircraft Spruce for the plans.
Okay. Now, if someone were to buy that set of plans from Aircraft Spruce, what kind of building times would they be looking at?
Well, it's pretty much like any other home-built airplane. It's about a 3-year project if you work on it 2 hours a day for 3 years. And that's what I tell just about everybody. You just got to grit down and get out in the shop every day for a couple hours and do it, and you'll have a nice airplane after 3 years.
So you're looking at between 1,500 and 2,000 hours to build it from a set of plans?
Yeah, that's what you're looking at. And if you can get a friend to help, hey, it's way faster.
Now, were there any special tools or knowledge that somebody's going to need in order to finish the airplane up?
Well, there's nothing special about these airplanes. They're the conventional way they're built, same as they've been since the 1930s, so there's no really any. You're going to have to learn how to weld chrome moly, but there's lots of people now that can MIG weld really, really well, and MIG welding works. So you can oxyacetylene weld it, or if you've got lots of patience and time, you can TIG weld it. But that's about the only skill that's really hard to learn. The rest of it is just the same as building cabinets, I guess.
Now we move from that up into some of the other models. What's the next model up from it then?
Well, the next model after this one here was the Model 1C, and it used the aluminum wing with a box aluminum spar, and see, this one here has the 912 in it, and the other, and it used an 8-foot wing instead of these wings panels are 9 feet on the biplane, and so we cut down on the wing area because there was a lot of trim drag on this the original one we built.
Now, the original has it been powered by 912 since day one?
Yes.
Okay. Now, what kind of performance would you be getting out of that? I mean, that's got to be a fast little airplane.
Yeah, well, the first time I flew it down to Oshkosh, I cruised at 110 at 5,500 RPM.
And what would the stall speed come in at?
All the airplanes stall at less than 45.
Now, again, you're using standard aircraft stick and rudder type of controls on it?
Yeah, they're just standard airplanes.
Any flaps or anything like that on it?
The reason they all stall at 45 and less is because under Canadian Ultralight rules, if the airplane will stall at less than 45, you can fly it with a ultralight pilot license, and that was one of our goals. We wanted people with just a simple ultralight license to be able to fly a really decently performing airplane.
So we've gone from a wood wing, and then we went to an aluminum wing, and what's the third stage then?
Well, the third stage is this one here. This one here is a fiberglass wing. It uses much the same construction internally, but it uses a fiberglass sheet to glue on the top instead of the plywood and fabric covering or aluminum. And if you do it right, you get a really, really smooth finish.
Very thin wing too, airfoil.
Yeah, that's 12% thick, but it's only 2 feet by 8 feet, so it's not like you'd need a lot of room to build something like this.
Now, why the third wing?
Well, there's quite a big story to that. After we built the 2 models of the biplane, we wanted to build a carbon fiber wing, just to really see if we could get and a much more higher performance airplane. So we started experimenting with different wing types. And along the way, I guess I don't know how it all happened, but we thought, well, if we're going to build a little simple fiberglass or carbon fiber wing, we might as well build it so we can use it. So kind of thought, well, heck, a triplane, that would be neat. Nobody's built a triplane since 1920. A new design triplane, that is, and it might be kind of fun. I did quite a bit of research on triplanes, and most of the research I found from the pilots that flew them, mostly in World War I, was that they really, really liked it. The Sopwith triplane and the Fokker DR-1, all the guys that flew them loved them. I didn't want to build a pseudo copy of a triplane. Another World War I replica. I wanted a new design, a sport triplane, something that used all modern technology and all the new what people know about aerodynamics. And it works. This thing just scoots along and climbs like you wouldn't believe.
Okay, now we're powering this with a 582.
Yeah, 65 force.
Okay, now again, we've got a stall speed of less than 45 miles an hour. What kind of cruise speed have we got?
It depends how hard you want to run the engine. If you run the engine where Rotax says its maximum speed is, it'll cruise at 100 mile an hour. But I cut it back, try to burn a little less fuel, because these 2-strokes, when you run them pretty hard, they burn fuel like crazy. But I flew this airplane down here to Oshkosh. I flew it at 5,600 RPM. It did 85 mile an hour, and it burned 3.8 gallons of fuel an hour. So
582, that's phenomenal.
So you can't do better than that.
Now again, we're still using standard stick and rudder controls on this?
Yeah, they're all, and the controls are very harmonious. They're not like a lot of airplanes where you got stiff pitch or light ailerons or heavy ailerons and light pitch. Everything is balanced. It's really nice to fly because it feels so good.
Now, this is a little unique, and this is the first time I've ever seen an aileron in the middle wing.
Yeah, we pondered on that, what we should do, and we thought about putting 3 small ailerons on, but then the linkage is a nightmare, especially inside of the cockpit where you got to get everything to work it. So I thought, well, these wings are really easy to build. I'll take a chance and put the aileron just on the middle wing and make a little bit wider one. You can see it's 2 inches wider than the biplane ones. And see if it works. And by golly, did it ever work. It turns like you wouldn't believe. The roll rate is a little bit slower than the biplanes to get it rolling initially. But once it starts to roll, and then when you haul back on the stick, that thing just goes around like you could turn it around in your living room almost.
Now, are you offering this then, or how is this airplane coming out to the market?
Well, all I'm offering plans, just the plans, that's all. You get the plans, you get an instruction book, and you get a CD with all of the digital pictures that we took when we built this airplane. We took pictures of everything to try to help. The biggest problem with guys when they're building something from plans is, how the heck does this really look? How does it look in the real world? And we got a CD with about 400, 500 pictures on it, and people can just load it into their computer, print it out, and say, hey, this is how it looks.
Now, what about the drawings? Are they like a full scale, or how are they the drawings for the jigs and stuff that have to be done?
There's 12 24 by 36 drawings, and the last 2 drawings are full-size templates. There's full-size templates for the ribs, the instrument panel, all of the fittings, all of the tail brackets. Everything has you can fit in a 24 by 36 piece of paper, a full-scale drawing. Just either glue them on the material or glue them on a piece of poster board for a pattern and whack it out with a bandsaw.
Now, what about the wing construction? You mentioned it's a composite. What type of problems is that going to be for the building? Well,
to do it the way we did this one here, I didn't recommend it. But you can cover this airplane with plywood if you like, and cover it with fabric. But we did this with fiberglass to get it as smooth as what it is. So what the builder would do is he'd make a normal wing structure, you know, built up. These are plywood ribs and a box spar wing, and you'd use a wooden leading edge notched out, and then you'd make these panels on a piece of arborite, like they use for kitchen cupboards, and the fiberglass won't stick to it. So you'd make that, lay it all up, trim it. As soon as it just nicely starts to harden up, trim it, and then glue it, lay it right on top and glue it. Done. Fast and easy.
Now, time-wise, is it longer to do that type than a wood wing, or would it shorter?
I think it's shorter, especially since the ribs are very small, very short. We cut them out 3 or 4 at a time in a router. You use the jig on a rudder. You can cut all of these ribs out in half a day.
If somebody wanted to get more information, how do they get a hold of you?
Well, the best thing to do is to check us on the internet. We're at www.acrolite.org, and all the information is there.